Okay, we're starting with the parent function. This is called the parent function. Page 6, y equals x squared. Let's graph that. Everything that we're looking at, all the transformations are always in relation to the parent function. If it shifts to the right or left or up or down, it's in relation to what we think of this like our starting point. Y equals x squared. Okay, so let's fill in the table. If x is 2, what's 2 squared? 2 times 2? 1 times 1? 0 times 0? Negative 1 times negative 1? Positive 1. Negative 2 times negative 2? Positive 4. Okay, so graph that quickly. And we know y equals x squared. The vertex is always at 0, 0, right? And then we have 1, 1, negative 1, 1, 2, 4, negative 2, 4. And it has to be symmetrical, right? Does that make sense? See, this is not... In every quadratic relation, so we're looking at y equals x squared. To graph this, we started at, look here, we started at 0, 0, the vertex, and we went over 1, up 1. Okay, I want you to write that down. We went over 1, up 1. Then we went over 1, are you looking? Up 1, 2, 3. We went over 1, up 3. And then if you continue, you would go over 1, up, what do you think? 5, exactly. 1, 2, 3, 4, 5. That would be another point. And then I would do the same thing on the other side. Over 1, up 1, over 1, up 3, over 1, up 1, 2, 3, 4, 5. And that would be the next point. And that, yeah, if you want to keep extending it, then we would go over 1, up, what do you think? 7. You notice a pattern?
It's 2.
If you were to graph this, look here, it's x squared. So where's the vertex? It's x squared minus 4. Where's the vertex for this one? 0, negative 4, right? It would start here. Does it have does A have a value other than 1? No, A is 1. So is it going to be wider or skinnier? Is it going to stretch or compress? So if you notice, all of these, A is equal to 1, which means none of these are going to stretch or compress. We did this yesterday. This one's just going to shift down 4. And it's going to go over 1, up 1. So I don't even have to fill in the table. You can after, but over 1, up 1. And then what? Over 1, up 1, 2, 3. That's the next point. Over 1, up 1, 2, 3. And then over 1, up 1, 2, 3, 4, 5. Over 1, up 1, 2, 3, 4, 5. And there's my parabola. It has the same shape as the first one because it has not stretched or compressed. It's just shifted down 4 units. Yep. Okay, so fill in these values. Use the equation. Use this equation, plug in x, figure out y, and then check your graph to see if it matches. It should. So for the next one, A is still equal to 1, so it does not stretch or compress, but where is the vertex located?
0,
Where's the vertex going to be for this one? 0, 5, so I'm going to do the same thing. Start at 0, 5, over 1, up 1 on both sides because it's a parabola, it's symmetrical. Over 1, up 1, 2, 3, over 1, up 1, 2, 3, and there's the last one. Okay, so this is the step pattern
for all of them?
for everything when A is equal to 1. Now, if A is not equal to 1, you're actually multiplying all of these times A, because times 1, it doesn't change it, right? So if the A value changed, you would do over 1, up 1 times A, over 1, up 3 times A, over 1, up 5 times A, over 1, up 7 times A. You have to multiply it by A if A is not 1. The first one, where was the vertex located? Y equals x squared. Where's the vertex? 0, 0. What's the axis of symmetry? X equals 0. Does it open up or down? Do any of these open down?
No.
They all open up. So they all have a max or min value. And I want you to write down what the minimum y value is. So for the first one, what's the lowest y value? 0. What's the minimum y value for the second one? For this one, y equals x squared minus 4. What's the lowest y value? -4, yes. The minimum y value is always going to be k. So what's the minimum y value for the last one? 5, good. Whatever our k value is, that tells us the minimum y value. And what's the vertex for the second one? 0, -4. The last one, 0. What's the axis of symmetry for all of these?
0.
Because they all start with x squared, right? It's not x plus or minus anything, it's x squared. The first one, what are the x-intercepts?
0.
0. And for the other two, does it have any x-intercepts? Does it cross the x-axis?
One of them.
No, it does not. If we extend this one, what is it? 2 and -2. Yes, my bad. Okay, don't worry about this right now. And I want you to sketch x squared minus 10 on the graph. Where would the vertex be for the last one? 0, -10, and follow the step pattern. So we're going to graph y equals x squared again. You can do that quickly. Parent function over 1 up 1 over 1 up 1 2 3 1 1 2 3 over 1 up 1 2 3 4 5 over 1 up 1 2 3 4 5. Okay, so after you can fill in the table of values and check that your coordinates are the same. So this one is y equals 3x squared. Where's the vertex of B? Where's the vertex located? 0, 0. So we're going to start by putting the vertex at 0, 0. Now it has a value of a that is equal to 3. So is this going to be stretched or compressed? It's going to be stretched. It's stretched by a factor of 3, which means our step pattern is going to be over 1, up 1 times 3, then over 1, up 3 times 3, then over 1, up 5 times 3, because it's stretching by a factor of 3. So you're going to see that the parabola will be stretched. So over 1, up 1 times 3 is 1, 2, 3. And you can already see that it's getting skinnier. Over 1, up 3 times 3. So what's 3 times 3?
9.
1, 2, 3, 4, 5, 6, 7, 8, 9. That's all I can graph on here. And I know it's symmetrical, so I can even just follow the pattern here. So it's over 1 and then up to here. And does that look like a parabola that is stretched?
Yes.
There you go. That's it. Okay, so for the next one, a is equal to 1 over 4, or you can write it as a decimal. What's 1/4? 0.25. So you're going to go over 1 up 1 times 0.25, over 1 up 3 times 0.25. Okay, so we're going to have to just estimate here. 1/4 would be approximately around here on both sides. And then over 1 up, so 0.75 would be around here.
And the next one's 1.
And then the next one is over 1 up 5 times 0.25. Over 1 up 1.25 would be around here. Okay, so use your table, but as you can see, it's compressed. It's wider, and A is a number between 0 and 1. Between 0 and 1. So we know it has to be compressed, it's wider. You can put these equations in Desmos and C as well. The vertex for all of them is 0, 0. At the origin, what's the axis of symmetry then? X is equal to 0. Do any of them open down? So do they have a max or min value? Min, what is the minimum y value for all of them? The vertex is at the origin for every single one. What's the minimum value then? 0. What are the x-intercepts? 0. And we don't need to do this.